So, hello everyone. I'm Gal Peretz. I'm head of AI at Caravan, where we develop basically AI voice AI agent for emergency response. So think 911, medical emergencies, and stuff like that. And also, I'm co-host and co-found Lang Talks, which is a podcast and a big community of 6,000 AI engineers. Today, we're going to talk about some interesting stuff because I guess most of you are familiar with the traditional tool calling JSON-based paradigm. And today, I'm going to show you a different one. And I think that it's super interesting because this one going to shake a little bit the JSON paradigm that was initiated by OpenAI and so on. So let's dive in. Okay, so this is the agenda. We're going to show the traditional tool calling, how this flow goes, like all the agents and the loops thing. We're going to wonder why even to invent the wheel and try a new approach. And then we'll introduce the new approach, which is called CodeAct. And then I will walk you through the technical aspect of that. And finally, as we all know, after this data science and workflow that we want to understand, what in it for us, and we will show the result. And also we'll talk about the key takeaway to take from this presentation. So how the traditional reasoning and acting works actually, right? So usually we have an LLM. It can be OpenAI, it can be open source, can be also Anthropic, and so on. Most of them already implement sort of like this JSON, tool calling. So you just give it the user task, right with the all the OpenAI schema. Also, if it's like MCP, it doesn't really matter. You still need to add this OpenAI schema to the LLM call. And then this LLM just output a tool call intent, right? It's not the execution itself; it's just the intent of tool calling in a format of a JSON. And then you hand it to the execution, or we are actually going to execute it. So we are responsible to call the specific function that the AI wants us to call with those specific properties. And then the output goes to the LLM and the loops goes on and on, right? So this is an example. Let's say that we want to search a specific price for a specific phone, but we want to search it in several countries and to know what are the cost-efficient country that we want to buy from. So the first is think, right? The LLM thinks what is going to be the intent of the user. Then it can understand, okay, I need to call a tool, so it outputs like this JSON with the name of the tool. It may look a little bit different, but it's similar to name of the tool, right, and the parameters. Then we are going to change the state of the environment, right? We are going to execute the function, change the state, hand it back to the agent, and so on and so forth. And basically, it can call one tool, but it can also output a few intents, right? A few intents for tool calling, and we are going to execute them in parallel. Okay, so what's wrong, right? It looks like it's going to work. This is actually power a lot of production-ready solution right now as we speak. So what's wrong with that? So let's talk a little bit about what's wrong. So the first one is when we want to express branches, right? If branches, loop branches. So let's take, for example, this task: get all user, and for each active user, deactivate his account, right? So what's going to happen? Let's say that we have a tool called get all users. So the LLM going to ask us to execute this tool. We are going to get the list of user. We hand it back to the LLM context window, and then the LLM going to say, okay, now execute. Let's say that we have a deactive function. Execute the active function a few times with different parameters, right? So if we have like 5 users, that's going to work just fine. But what if we have 10,000 users or 100,000 users? I can assure that it will fail, right? Because a lot of problem, right? The lost in the middle effect, the LLM attention mechanism cannot attend to those like this amount of users or information, and it will like call the active function with few users, but for sure it will miss a lot of them. The next step is the fact that actually those like OpenAI fine-tuned models and any other vendors were fine-tuned to output and also to get a specific JSON schema, right? So what works with that? If we have a fine-tuned object, a fine-tuned model, we need a fine-tuned pipeline, right? We need to get the data, right? To construct a loss, to fine-tune it, and then we have versions, right? So from time to time, we need to refine-tune it with other action that it will, we will make sure that it will output the correct output according to the format. So basically, it's a pipeline, right? But the fact that it's specific pipeline for a specific task, compare, for example, to model that generate codes. So you can be certain that, like, for example, the pace of improving those code generation models is way faster than improving those fine-tuned LLM that should output those JSONs, right? Another aspect is that it's very hard to represent nesting objects, right? So types, nesting types, any sort of that, it's very hard. So let's take an example. These types, we have those pedantic types. We have departments, right? We have company, we have departments, which is a list of department, and then we have also employees, and the employees has also address. How we going to represent that in a JSON, like with the OpenAI schema? It looks something like that. Okay, so it's a pretty nasty representation, and it's not just nasty for us. It's going to confuse also the LLM. And think of that. This is just the parameter of the functions. We have also the context. We have also the intent. We have maybe also have the history of the conversation. So it can create a lot of noise. Another aspect is how we can represent composability, right? So what does it mean when we have a function, right? And we have the output of this function. We want to take this output as an input to another function. This is very hard in the current mechanism that we have, right? Because when we execute, for example, the get all users, so for once, like, we don't have the output, right? Those like OpenAI schema only represent the input, right? They represent the parameters that you need to input. But we don't have any idea what's going to be the output, or at least the LLM doesn't have any idea. So basically what we need to do when we have the output from get all user, we need to hand it back to the LLM to decide what you want to extract from it to put it in as an input in the compute happiness function, and so on and so forth, right? It's very hard to represent composability like that. And the last one is basically the action space, right? What does it mean, the action space? So in the traditional aspect, we have function that we define. Maybe we have MCPs and so on and so forth. But anything that we haven't think of from the right perspective. So, for example, let's take this task. Tell me how many active users we have in our system. So let's define that, right? Maybe you model the get all active users because you thought that this agent going to serve user request and it's going to need to understand who are the active users. But then this specific task also require you to aggregate those users, right? So what's going to happen is basically that we get a list of active users, and then we will hand it back to the LLM and count or trust on him to actually use his reasoning capacity, right, to aggregate those and hand out back the output of how many people that are there, right? So, and I think that I would prefer that OpenAI will show me, or any other vendor, that they can count very well the R in Strawberry first, and then I will count on them to count stuff in production. So I hope this like give you an idea why we need a new paradigm, and this new paradigm called CodeAct, right? So the idea, the notion is very easy. Instead of output JSON, let's write code, right? LLM great in writing code, so let's do that. So the idea in the first place is very similar, right? We plan, we thought, right? We need to understand the intent, and then instead of outputting JSON, we will write Python, right? We just emit the Python, and then we'll need a sandbox execution environment. After that, the LLM will observe, but actually here in this step, it can observe and understand if there were any errors and stuff like that. And then it can revise. In the next step, it can revise the code, right? If error record, or maybe you can see from the prints, from the output, that we are not in the right track, on the right track, so we can revise the code and we will execute the code again. Okay, so very similar notion, but different approach. Let's see, in the technical aspect of things, let's see how we're going to represent the LLM functions in the aspect, like in the terms of before when we use the JSON, and after when we use CodeAct, right? So here we have, for example, this function, and to represent it to LLM, we need to append it in the metadata in the request, this kind of nested object, right? For the code, we can just define as we are usually define functions in code, right? Why do we need to define different type of, notions, types, different things of stuff to represent LLM what we want it to do, right? Is already fine-tuned on how to write code, how to understand code. Let's zoom in and understand the flow. So basically, this one we already walked through. So how it works, instead of just act on a specific action, we are going to write code. We are going to use the loop and the if and all that, this magic that already available in code. Also, we can use, for example, min, which tool that we are not really defined in the first place. We can use it because we are writing code. We can also use, for example, pandas and aggregate on the fly, right? We don't really need to define that. So this is basically the system prompt. We are just give it a restriction. What kind of, you have access to the internet, you don't have access, you do have access to file, to write to file, to read to file. Just limiting the search space, because just give the LLM the ability to write code can take it to the other way, and instead of like, we will give too much dynamic in the system, we will have free variables there, and it won't converge. So this is how the system, and this is how the user prompt looks like. Basically, you want to omit the body, because maybe in the implementation of those functions, we have function that we don't want the LLM to use. So let's jump, because we a little bit out of time. Let's jump to the results. So basically, you can see here, the interesting thing to see here is that you can use a very small model with CodeAct, and it's competitive to actually using a bigger model with JSON schema, right? So this is specifically for dataset that are workflow-based and tool calling and so on. And I see that we are out of time a little bit, so just key takeaway. When to use CodeAct: when you have workflow-like, when you need branching, we need to dynamic. You want to put the time and effort to customize your environment. When do you want to use JSON-like? When you want the plug-and-play solution, when you don't really have any complex task, and when you want a low latency because you just call an API and that's it. Thank you very much. Please connect to LinkedIn if you have any question. And
awesome. This was incredible. We did have a question in the chat a little bit earlier on. Elad from Solara AI asked if you recommend fine-tuning, or would you say that libraries like TrustCall are enough?
So fine-tuning meaning the fine-tuning the CodeAct paradigm, or fine-tuning the model that use CodeAct?
That's a great question. I'm not quite sure what he meant. I think he was asking this question before you had introduced CodeAct, and you were talking more about like JSON tool calling and some of the barriers to it. TrustCall is, something that helps make that a little bit easier. Maybe the question, taken further is really, how does TrustCall compare to something like CodeAct?
Yeah, basically, it depends, right? It depends what you use. If you use a very capable model like OpenAI, GPT-04, or so on, so I guess like Trust can work. But if you, for example, use open source ones, you want to fine tune them to really, restrict the output to bound to those like OpenAI schema JSON.
Okay, cool. Yeah. Totally makes sense. Curious whether, maybe just like one more question before we like switch off. Just curious whether you experience any cases where the openness or the unconstrained nature of just generating code becomes an issue. Like you can kind of like generate a program. And what do you do to kind of like control for that?
Yeah, for sure. So I had a slide for that. Unfortunately, yeah, for sure. So you can use, like, for example, a tool like abstract syntax tree and linters to understand before you even execute the code if there were a typing error or stuff like that. And abstract syntax tree, you can, for example, analyze the code and spot any forbidden like functions that you don't want the execution to call, and then reiterate on them. And usually we are actually want to restrict the LLM based on the prompt, and to give this like to limit the search space, because it's very similar to any data science problem. When you have too much of freedom, it's not going to converge. But if you are expressing and seeing like the JSON like when like we are using those JSON based paradigm, and instead of give it freedom, it's less it doesn't have the power to express like this workflow. So I think that the play here is to understand how to push the boundary when you need to, but give the restrictions, and have the tools to give the restriction when you need to.
Totally. Awesome. Thank you so much for joining. We're gonna mosey on over to our next speaker. Feel free to get that QR code, connect with Gal on LinkedIn, or find him, Gal-Peretz on LinkedIn. But yeah, thank you for coming. Really enjoyed it.
Thank you for having me. Bye-bye.